Okay, good morning. Well, Jason, it seems like it's going to be the two of us, but I think I need to start. I don't think we can wait too much longer. I think it's going to be one of those chapters that it will take a lot of time from everybody to grasp. So unless you have any question, I'm going to get started with this. Okay, so anyway, just think about any question that you have in prior chapters or on this chapter. Okay. So in this chapter is going to be very important because we're going to be talking about in more details about the input and especially the output. Also, we're going to be looking at how do we process files. So the main idea is that we have to think about the input and the output as a stream. Now, what does that stream mean? Well, think about it like it is a bus. And on this bus, we have seats. So what happens when somebody is sitting at the computer and typing on a keyboard? Okay, that's my computer right there. Okay, so what happens if you press a key? Let's say you press A. Okay, now what is the equivalent of A? Now A is going to be 65 in decimal, or it is going to be 41 in hex value, or base 16. So now, when you press the A character, what happens is it gets into this bus, and you get the very first seat. Okay, so you have A stored in here. And that's going to be the 0th position, 1st position, 2nd position, 3rd position, and maybe the 4th position. Okay? So then you press B. Well, B is 66. Okay? Let's see what happened here. Okay? So B is 66, that's going to be stored. And then you press C, which is 67, and so forth. Every single seat will get a single character. And the bus is going this way. Okay? That is the stream. The stream is basically one character at a time, one after the other. So what is it that we're going to do when we trying to get something? When you get something, you're basically extracting it from the stream, extracting a character. Or sometimes you can get a group of character. In a case of CIN, if the CIN reads a character, it's going to be just 1 byte. If the CIN reads an integer, is going to extract 4 bytes. So when we're talking about get, think about get as kind of like this is a bus. Okay? And the bus is going in a particular direction, and then you're getting people off of that bus. Okay? So what do we do if we ignore? If we ignore something, okay, maybe we got A off this bus, and now we are pointing right here at B, and we want to ignore B, we want to ignore C, we might want to ignore D, so we might ignore 3, and then we arrive at E. Now when we are at E, we can actually peek and look at who is sitting on seat number 4. But when we are peeking, it's not the same thing as getting, because when we peek, we're just looking at it and leaving it alone. While we are getting something, we're extracting that particular location, and then we move everybody forward. So if we're getting A from seat 0, then B moves forward 1, C moves forward 1, D moves forward 1, and E moves forward 1. And if we have a character, wherever we're pointing, so let's say we ignore 3, we're pointing at E, and when we are at E, we're gonna get E, so that means we removed E. But then we change our mind, and what we can do is maybe we can put the same E back, or put something else back into that string. Okay? So think about whatever you do on the keyboard, they're all going to be in one long string, and that's what we're going to be focusing in this chapter, that one string. So we need to figure out what happens if the user types in something that we are not expecting, and how do we handle that error condition. And that's what we call the input failure. So so far what we were talking about is in, let's say, output. Okay. The main idea here is going to be that we only said in cout that maybe we're going to have an expression, or we might output a variable. But when we outputting something, when we are printing something out, how do we know where that's going to show up on the screen? And that's what we're going to be working with when we're talking about manipulators. So we're not just allowed to output the result of an expression or the value of a variable, but we also can manipulate where that shows up on the screen. So an input and output stream is basically a sequence of bytes or stream of bytes from source to destination. Now the stream can be source, keyboard, and destination, your program, your application. Or the stream can be an output stream where you're talking about the application, and the applications going to the output device, and in most cases it's going to be the screen. So the stream excuse me. So the stream is a sequence of characters from source to destination. The input stream is a sequence of characters from an input device to a computer. And the output stream is a sequence of characters from computer to an output device. Okay? Again, back to the bus ID, right? You can see that this is a stream, and the bus is going toward a destination. Now, if this is coming from the keyboard, going toward the computer, that's an input. If from the computer or your application, you're going toward the output device, right? So eventually, all this is going to be going to the screen. And if we got A, we're going to actually display A on the screen. Okay? In order for us to process that A, we have to do something in between, and that's where our application comes in place, that your source file or CPP file is going to tell the screen where and how to display those characters. But all of that's going to be depending on this input stream. So make sure that you understand basic terminology. And then when we're talking about input and output devices, just make sure that you understand the libraries involved. So far, every time when we try to deal with input and output streams, we looked at the IO stream header file. Now, the IO stream is a combination of processing input and output streams. Now here, the data type is either iStream or OStream. So when you're talking about iStream, CIN is a variable of iStream data type. Okay, so data type, think about it like when you say integer X, right? X is an integer data type. Here, remember CIN is a predefined variable. So CIN is an iStream data type. It knows how to handle the bus. It knows how to handle the stream. So then Cout is an output stream, which is an OStream data type. So that's why we have to include the IO stream header in order for us to process input and output from users. So the variable declaration is the same thing as with primitive data types, but iStream and OStream is not primitive. It has a lot of structure inside. So that's why we included the library. So the library is IOStream, and that needs to be processed by the preprocessor. So when we use CIN, we are really using a stream extractor or a stream extraction operator, which is the greater than signs. So we are extracting passengers from the bus, right? So let's go back over here again. So the passengers are sitting on a bus as you are typing the keys on the keyboard, and then you're getting all that. Well, CIN also gets all these passengers off, and that's why you call, what is that operator that extracts it? Well, we have the stream extraction operator. Now the stream extraction operator is binary, so that means you have to have the CIN on one side of it, and then you have to say where to extract the data into, and that's where we have the variable. So on the left side we say CIN. What is CIN? It's an iStream, an input stream variable, and that input stream, when it extracts data from the input stream, it needs to store it somewhere. It stores it in a variable. So there is no difference between a single CIN with multiple variables and the multiple CIN statements with one variable. So when scanning, the stream extraction operator skips all white spaces, blanks, and certain non-printable characters. So how do we distinguish between character 2 and number 2? Well, character 2, it depends what the binary operator is processing, right? So if we have a character X, and then we have an integer Y, okay, and then we're going to do CIN X and then Y, then the stream extraction operator first looks at, I need to get one single byte off that bus, one single byte out of the input stream, and then I need to get an integer off of that input stream. So the way that we distinguish when we program, what needs to be read, is it a character 2 or a number 2, is determined by the data type of the variable where you're storing the data. So you need to know what variable you're reading it into. So there are some rules. This table is very important. So a character is one printable character except the blank. So CIN by itself will not read a blank or a white space. An integer, how do we read that? We read that by either reading the unary operator if we have it. So you can have a preceding plus or minus signs, and then the number, ignoring the space, the leading space and the trailing space. A double is a floating point value, so in that case you still have to look at the leading sign, the unary sign, either positive or negative value. If the input is an integer, then the input is converted to a decimal number with the 0 parts. Okay, so let's see if we have, again, we have a bus. Okay, so we have this bus, and in the bus we have these seats. Okay, so let's say somebody types in 5 and then 5 space plus 18 minus 15.5. Okay. So to us, it just looks like on the command prompt, somebody just types in 5 space plus 18 space minus 15.5. Remember, it is a stream. So the stream, you're putting it into this 1-byte character. We're going to eventually call them an array. Okay, but it is a structure. So, but that's what it looks like. And even if the cursor is blinking right here, let's say the cursor is blinking here, so we have some leading space, right? So there's some space in front of 55. Okay. Now, if we use, let's say, CIN, okay, so we say, not that. Let's say we have character X, and then we have integer Y, and then we have, let's say, float Z. And then we're going to say CIN X, Y, and Z. So what happens then? Well, CIN looks at the string and ignores the space, ignores the space, ignores that space, right? Because that's the rule of CIN. And then it sees a digit. Now, there is not a plus or minus sign in front of it, so it looks at it. What is it that I need to read? Oh, I need to read a character. So then X is going to read 5. 5 is because X is a character data type, so it can only hold 1 byte. So you only read 1 byte. So then you have Y. And what is Y? Y is an integer. So integer is read by looking at, is it a digit? Yes, 5 is a digit. What's the next character? Next character is space. So I need to stop reading. So Y in this case also going to be 5. And then finally you're reading Z. Now Z is a float data type. Okay. Now what is the rule for float? Okay, we're going to ignore this space right here, and then we look at the plus sign. The plus sign is just interpreted that this value going to be, the binary value going to start with a 0. So it's not a negative number. So it's not really read, it's kind of interpreted that it's going to be a positive number. But the plus sign itself is never really stored. And then you look at the digits. So 1 digit, 2 digit, then we see a space. Because we see a space, we stop reading. But because Z is a double or a floating point data type, 18 not going to be stored as 18. 18 going to be stored as 18.0000. Okay? So either 6 or 7 zeros based on what compiler you're using. So the stream still has minus 15.5 in it. So we either ignore that, we're going to clear that, or do something with it. But the stream has this because the user actually pressed enter, right? After the user typed all this in, the user pressed enter. So all that is in the stream. So that's going to cause a little bit of confusion later on when we do some exercises. So when reading data into a character, then the stream extraction operator skips leading white space, finds and stores only the next single character. And the reading stops after the single character. So the book is very good at explaining how that actually works and gives you really good explanation and really good examples. So it's gonna be very important that you guys read the chapter over and over again and not skip any portion of the chapter. So when we read into integer or double variable, then stream extraction operator will skip the leading white space and then reads the positive or negative sign if there's any. And then reads the digits, including the decimal point and the digits following decimal point, until it sees either a white space or a non-digit character. And these are the examples. Right? So it's going to be very important that as you guys are reading through the book, okay, make sure that you do have your compiler running. And as the compiler runs, you have to do these exercises. Okay. So let me see if I can share the desktop. Okay. That's not it. Okay, here it is. Okay, so we have Visual Studio or whatever compiler that you are using for this class. So now what I need to look at is I need to have access to my source code. Right? So you downloaded your source code, you extracted it, and you have it on your hard drive or your thumb drive. So now, instead of adding a new item like we did in the first assignment, what we do is we adding the existing item. And then we go to our source code, and then we try to find a assignment. Okay. I don't know if I have the exact assignment. But that's okay. Let's just open up one of them. Okay, so the main thing is that you're going to have a source code added to your project. Okay. And last time we talked about, I would suggest that you guys have one single project for learning and just call it driver. Okay. So here you can see that we have some input And the input going to be first read into a string. String is a name. And then we have age. Age is an integer. Then we have the weight. And then we have height. Okay. Now here it's going to be important that you use the debugger, okay, like we were talking about last time, just really to see what happens. What really happens in these systems as they read user input. So I want to see what happens after I declared all my variables. Okay? And then after the declaration, I want to see how those variables change as I'm typing something in. And then later on, we can also look at what happens as far as the output is concerned. Okay? So you have a source code, you did not have to really type anything, but just run this code, and then you go ahead and compile it. The first time will always take a little bit longer. Okay. So we have our code, and we have the terminal window. So kind of adjust it that you can see both of them. So there's nothing right now. We have a blinking cursor. Okay. But if you look at your locals, okay, you can see that the locals are declared and initialized to a particular value. And then we continue on. And now we have the actual display. Okay. Now the cursor is blinking after all the display. And that happens because when we outputted the text, we did not put in the ENDL, or the end of the line. So that's a design decision. You can do it either way. So some people like it this way. Some people like it the cursor blinking on the next line. Okay. So here we need to type in age. So let's say a name. Space, remember space is the delimiter, and then we have, let's say, age, and then we have weight, and then we have the, let's say, height. So when we type it in, you can see how these values actually change based on the user input. So this is what I typed in. And you can see that CIN read the string first, right? Why did it read it as a string? Because I told it to read it as a string. Okay, name is a string, so it read string, which was Richland. Richland was ignore the leading spaces, read all the characters until you find an empty space. So at that point, it jumps over, and the stream extraction operator was trying to store information into age. Now, age is an integer. Now, I'm reading 15, and 15 is the actual age that's going to be stored. Why is only 15? Because after 15, we have a space, and space is the delimiter. Then the weight was read, and the weight is an integer, so it was read as an integer. So right now we have 120. And then the height I typed in as an integer, no fractional part, but it was stored as 6.0000 because it was a floating point data type. Okay, so then we can go to the next. And now you can see that we have an output. An output because we have a literal string followed by all the variables. So we need to know how do we read in, and what is the data type? What is the variable that can hold that data type? Okay, so let me take off these initialization. Okay, and let's rerun this code. Okay, now you can see that the string by default is an empty string. There's nothing in it. The height, age, and weight, they all contain garbage values. Okay. So what happens if we continue and we try to read a value into these variables? Let me put it right here. Okay. So I have Richland, and then the age, let's say 18, and now we have the weight. Now the weight is an integer, right? So it is an integer that I'd like to read in. But maybe I'm going to say I am 150.4. And then I need to type in my height, and my height is, let's say, 6.8. And then I press enter. Okay. Let's see what happens now. So what happened in this case? Well, name is a string, so that's perfectly fine, right? Because Richland was red, and all the way to the space, and that's fine. And then we have age. Age is an integer. 18 was typed in. Now 18 is red, the 1 and the 8, and followed by 0, so we stop reading right there. So we only store 18. Then we have the weight. Now I typed in 15.4, but 15.4 is not an 150.4 is not an integer. So what is an integer? 150 is an integer, followed by a white space or a non-digit character. So we have to stop reading right here because we are storing the value into an integer. So what was stored into that? Only 150 was stored into it. And after that, what is it that we read? Well, we're reading the height. Now the height, I wanted to read 6.8, but what is still in the stream? What is still into the bus? What is sitting on this bus? 0.4 is still in the bus because we only extracted 150. So at that point, we stop reading. So CIN looks at height, and the height is a floating point type. So what is the rule? Read the positive and negative. Well, there is no positive, negative in front of it. So then read the whole number, and the whole number, the integer part of a floating point value, is not there at all. So then reads the next character, and the next character is a period, and the period is perfectly fine for a double value. So it reads the point and then reads all the digits after the point until it sees a white space. Now in this case it's only 4, so it stops reading at 4. Okay? When it reads at 4, it stores 0.4 into the height variable, and we still have 6.8 sitting in the bus. Okay? And you can also see that in this case, you see that 2 at the end, that's just a rounding. So computers, when it comes to floating point values, they're not storing the exact value. They're kind of rounding it and estimating it. So working with floating point value requires you to understand a lot more about how computers store data. Okay, so as we continue on, right, it's kind of strange that somebody says, okay, your height is 0.4. and that's not what my intention was. So if we don't understand how CIN works, and we don't understand data types, we don't understand what users will type in, then we might have some strange results in our programs. Okay, so let's do another example. Okay. And here, oops. Again, we have all the garbage values, and with the garbage values we continue on. So now we have a prompt, and at the prompt we type in the string, which is the name, and after the name I type in age, and right after age I'm going to type in A. And then I'm going to say the weight, 120, and let's say the height is 5.4. Let's see what happens now. Okay. So at this point you can see that the user typed in something that did not fit our way of reading that information. So the name, again, is a string, so it was perfectly fine. And then we read the age. And when we read the age, the rule is ignore the leading spaces, read the positive or negative value, and then read all the digits until you see a white space or a non-digit character. So we read 20, and the 20 was stored in age. And after that, who is the first on the bus? A is the first. But what is it that we're trying to read? We are trying to read weight. And what is the rule? The rule is to read or ignore the leading spaces, read positive and negative, plus sign or a negative sign, and then read the digits. Well, there are no digits. This is a character. So if there's a character, then the bus stops. Basically, it stops. It doesn't do anything. It goes into a failed state, and at that point, the program continues, right? And you can see that we can continue with the program. But look at the output. Okay. Now, what is that? These are the default garbage values for integer and for a double data type, and that would be really strange. If we would not understand what happens if the user does not type in the correct information in a correct sequence, then we would have really strange results. Okay, I don't think you would be very happy with this weight and height when it displays. And that's why it's also important to understand the default garbage values for all the data types, because as soon as you see these numbers, it automatically tells you something went wrong with the input. Okay. So you can see that with this sample code that comes with your book, you can do a lot of testing and a lot of learning, especially if you're using the breaks. Okay. So if you have the breakpoint set properly, and then you understand how to follow the variables, you're going to learn so much more from the chapters. Okay, so make sure that you do use the in-chapter code or the in-chapter exercises. Do it in Visual Studio. Do it in your compiler, and not just read about it from the book. Okay. So, this is where you have this example, right? So you have the integer, the double, the character. The author shows you what is the input and what is stored in memory for that type of an output or that type of an input. It's very good examples. Okay, so make sure that you go through all this and let me know if any of them do not make sense or you need more explanation on those. Okay. So you have a lot of examples, a lot of help to help you understand how that works. So what do we do when we use predefined functions? A function is a sub-program. So a sub-program is basically an instruction that accomplishes a particular task. So main executes when a program is run, and main is a function. And main is the enter point for our applications, and that from main we can call other functions. So these other functions are organized into a collection of libraries, okay, and those contain headers. So really, a collection of header files is called a library, and that's what we have when we use the IO stream. IO stream is the library, and inside the IO stream we have header files, a collection of header files. So header files contain the functions. So in order to use the predefined function, you need the name of the appropriate header file and or the appropriate library. So this is when I think we talked about this whole concept of the watering can. Okay. So function, let's say this can is called func1. Okay. So we need to know the name of the function. What is going into the function? We need to have the parameter list. Where is the parameter list? It's between parentheses, and the parameter list items are delimited by comma. So X, Y, Z. So in this case, I have 3 parameters because we list these parameters by delimiting by comma. We might not know what's inside exactly what's inside the can, so we don't know the code. We don't need to look at the code or understand the code. What we need to understand is the data type. What is the actual data type for each one of those parameters, and what is that comes out of this watering can. Okay. Okay. So basically, the most important thing is what is the data type, because we're going to have to store that or work with that, whatever comes out of the watering can. Okay. So one of those functions is, let's say, POW. You want to raise something to a power. Okay. Then we need to use, first of all, in order to use POW, we need to have the preprocessor. So with the preprocessor, we have include, right? And then we have to do the CMAP. And now we have access to a POW. Now with POW, what are our choices? Okay. Well, first of all, we need to figure out what is this parameter list is. So whatever is the first value within the function, it's going to be your base. And the second value is going to be the exponent. Okay? And then we need to figure out what do we do when we receive this value. Okay? So let's go back to our code, and let's just do include. So we have CMAP, right? So now what we can do is we can actually do a call. So there's going to be POW call or POW function call. Okay, so when you type in POW, see, as soon as you type POW and the open parenthesis, you're going to see how to use this method or function. Okay, so here you can see the double needs to be the base, comma, double is the exponent. And that's just 1 out of 7 ways to use this. So I need to look at the second one. So if you look at you click on the down arrow, right, you can go up and down, and you can look at all of these ways of use this function. But you can see that we can call this function with a double as a base, an integer as an exponent, and then double will come out of it. Okay? So if I want to use this, let's say I'm going to say double result equal POW, okay, I'm going to send 10, and let's say I want to raise it to power of 2. Okay. Do I have to say 2.0, or can I just say 2? Well, in this case, this is an integer, right? So if this is an integer, that means right now, right? And later on, we're going to learn how to create our own function. So you guys are going to learn how to write your own function. It's going to make much more sense. But you can see if you just highlight on the POW, now you can see exactly which one was selected. So look at the data type in front of the name is double, right? So double comes out of it. What goes into this watering can? A double, which is x. X is the base. And then integer is the exponent, the way I've written it right now. So what happens if I change this to 2.0? Are we still calling the same function? Well, not really, right? You see the parameter list? Now it's double comma double. And also notice the underscore, the usage of underscore. Remember when we said the variables have a rule, and in the variable rule we do not use the underscore to start the variable's name? You can see that this is basically those who wrote the IDE, those who wrote the actual function for C++, for the standard library, they use the variables that do start with underscore. And when we discussed the variable rules, we did talk about the rule that this is kind of like a convention that most people use, that you as a programmer, you never start your variable, your identifier, with an underscore. Okay? We let those programmers use the underscore-based variables that maintain the actual language. Okay? So this is how you use the functions. Okay? And this is also one of those times when we can maybe talk about that you should go to CppChapter3Session1.com. I hope I can go there. Well, this takes a long time. But if you go to C++, that's going to be your reference. It's a really good reference, and then you can search for POW. Okay, here's the POW, and it also gives you a short explanation of what POW is. Right, returns a base raised to the power exponent. Okay, so when you have the explanation of what this function does, it has a lot better variable naming convention used, not just x and y, but it tells you that the first variable is the base, the second variable is the exponent, and a little bit more explanation. So if you guys need a little more explanation, this is the website that I would recommend that you go to. Okay. So let's just stop the program right after that and see what happens. See what's going to be stored in that variable called result. You can see here I'm declaring the result as a double, and at the same time I'm also initializing it to 10 to the power of 2. And now you can see that result actually has 100 stored in it, and the data type of it is double. Okay, so that's how you use a predefined function, right? So we needed to know the library. Okay, and if I look at the library, okay, and I open up this library, you can see that it has, see, there's the math.h file. That is your header file. Okay, so files that have .h file extension are the header files. So you can see that when we use the library CMAT, that CMAT is really a collection of other header files, and that's why this is called the library. And now POW is available to us to use. Okay. So why would you use another function? Why would you use a function called, let's say, cin.get? And cin.get, we're sending that function a variable called var_char, which is, that char is really a character data type. What does that mean? CIN will extract a single character and store it in a character variable. Okay. Now that dot operator is kind of strange. Okay. So kind of think about it like CIN is this big box. Okay. So we have CIN, and within CIN we have a function called get. Okay. Now get has an input parameter, which is a character variable, okay, and it will return something back to us, and the return also going to be a character. Where is the return value going to be stored at? In this character variable. Okay. Now CIN also going to have other things, right? Like we're going to have peak. Okay. We're going to have ignore and all these different things. So the dot operator, think about the dot operator as the operator that allows you to get inside the box of CIN. So it is called a member access operator. A member access operator is basically allowing you to get into the box and extract the specific functions, subcode, that do specific things. Okay. Now when we have ignore, remember what an ignore does? People are sitting on a bus and you ignore a few rows of people before you get to the next row of people that you're actually gonna get. Okay. So the integer expression is basically telling you how many characters to ignore, and the character expression tells you if you don't get to that number of characters, then number of values, then what is the character that will allow you to delimit something? So let's say here's your bus, okay, and you want to get A, and you're gonna use get for that one, and then we also have B, C, D, and E sitting on that bus, and now you're gonna say, let's say, CIN dot ignore, let's say 2, or if I get to the new line character. Well, we are ignoring 1, we are ignoring 2, okay? So then we can get D next time and leaving B and C alone. But if the user actually typed in let's say A, and then we have B, and then the new line character. So the user only typed in A and B. That means we do not have two values to ignore. Then the next value is the new line character, and at that point stop reading or stop ignoring things. Okay, and that's the concept that's going to be important in order to understand how we actually going to use the how we're going to reset the failed input stream. Okay, so if the failed input stream is processed, then we can reset it and keep reading it. And that's what you're going to be also reading or presenting or practicing, basically, with the sample code that comes with your book. So you have a really good example for this. Okay. Anyway, so this should be enough for one day. Okay. So this is just the first half of chapter 3, and then next time we're going to be talking about output manipulation and how do we handle files for input and files for output. Okay, but make sure that you practice 3 or 4 sample codes from this chapter 3 before next time, and bring in some questions for any concept that might not make sense. Okay, so see you guys next time.